Hi students, welcome to online class. This is video module 1. I have some coins in my hand. Let us count them. 1, 2, 3. When you want to count the things or the coins like this, you will start with 1. Now, if you observe my right hand, how many coins are there in my right hand? 0. That means not only 1, 2, 3, 4 are the numbers, in the numbers 0 also includes. Like that, if you observe the temperature in the coldest countries, the temperature will be minus 5 degrees, minus 10 degrees, minus 20 degrees Celsius, like that will be. That means the numbers not only 0, 1, 2, 3, 4, we have some negative numbers also. Like that, if I have an apple, I want to distribute the apple equally among 2 persons, then each will get 1 by 2. If I want to distribute an apple among 4 persons, then equally, then each will get 1 by 4. The same apple, if I want to distribute among 8 persons, each will get 1 by 8. From this, what you notice is not only 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, 4, we have some numbers 1 by 2, 1 by 4, 1 by 8 also. That means the numbers not only counting and 0 and negative, we have so many numbers. Can you guess where we will discuss about all these numbers? Yes, that is number system. So in number system, we categorize these numbers in different categories. First of all, natural numbers. Natural numbers are the numbers which we use to count the things or the objects, like 1, 2, 3, 4. Natural numbers are denoted by the letter n. That means n equal to set of 1, 2, 3, 4, so on. The least natural number is 1. Whole numbers. Natural numbers including with 0 are called whole numbers. In whole numbers, the least whole number is 0. And the whole numbers are denoted by the letter W. And the greatest whole number we can't say. The whole numbers including with negative natural numbers are called integers. In integers, we represent with Z. Z means Zahlen. It's a German word. Zahlen means counting. Here, Z equal to set of 0 plus or minus 1 plus or minus 2 plus or minus 3, so on. The negative integers are denoted by the letter Z minus. The positive integers are denoted by the letter Z plus. In the negative integers, the least negative integer we can't say. The greatest negative integer is minus 1. And the in positive integers, the least positive integer is 1. And the greatest positive integer we can't say. About 0. 0 is neither positive nor negative. Like that, if the numbers of the form p by q, that means in the form of a fraction, and p comma q belongs to z and q not equal to 0, that means the denominator should not be 0, then the numbers are said to be rational numbers. Rational numbers are denoted by the letter q. Why we are taking the q not equal to 0? That means denominator not equal to 0 means if the denominator becomes 0, the value can't be defined. So that's why we are saying the condition as q not equal to 0. That means here, if you observe carefully, natural numbers are the rational numbers. Yes, natural number is a rational number. Why we are saying the natural number is a rational number? Here we have an example. If you take 5 from the natural numbers, 5 can be written as 5 by 1. That means it is also in the form of p by q. That's why we are saying the natural numbers are the rational numbers. Like that, whole numbers and integer also be considered as rational numbers. Like that, from this what we can say is natural number is a subset of whole number, and whole number is a subset of integers, and integers are the subset of rational numbers. Now, if you observe carefully, here we have a question about this topic. What is the successor of 5? You will say in natural numbers means it's a 6. What is the successor of minus 3? In integers means you will say as minus 2. Then what is the successor of 4 in rational numbers? If you say it's a 5, then it's a wrong answer. Because in rational numbers, there exist infinitely many rationals between any two rationals. This is called property of density. Find 5 rationals between 1 by 2 and 3 by 4. So if you observe these fractions, you can't say the 5 rationals between them directly. Then what the procedure to find the rationals between the given rationals is, if you observe first the denominators of these fractions, they are not equal. When the denominators are not equal, we can't say the fractions directly. So first we have to make the denominators as equal. To make the denominators as equal, what we have to do is find the LCM for the denominators. So the LCM is 4. So when the LCM is 4, we have to bring that LCM value to the denominators of the fractions. So to get the LCM value here, we have to multiply and divide with 2. Why we are multiplying and dividing with 2 means, the fraction rule is what the value are going to multiply to the denominator, the same value multiplied to the numerator also. So in 3 by 4, no need to multiply because the LCM value here in the place of denominator. So leave the fraction like that. Now the value changes as 2 by 4 and 3 by 4. Don't think that we are changing the value of the given quotient, just we are presenting the quotient given fraction in another way. So if you observe now, the fractions denominators are equal and the fractions are 2 by 4 and 3 by 4. Now also we can't say the 5 rationals between them directly. Then what we have to do is, we have to multiply and divide the given fractions with 5 plus 1, 6. Here we have a doubt. Why we have to multiply and divide with 6? If you multiply and divide with less than 6 or more than 6, what will happen? If you multiply and divide with less than 6 values, you will get less than 5 rationals. If you multiply and divide with more than 6, then you will get more than 5 rationals. So here 6 is the right value which gives the 5 rationals between them. So here I multiplied and divide both the fractions with 6. And the result is 12 by 24 and 18 by 24. Now we can easily say the 5 rationals between them are 13 by 24, 14 by 24, 15 by 24, 16 by 24 and 17 by 24. The 5 rationals are 13 by 24, 14 by 24, 15 by 24, 16 by 24 and 17 by 24.